If you run a plant, a hospital, a school system, a city, or a big commercial facility, and every time you open the electric bill, you see a giant line item for demand and think, I don't really know what this is, but it's huge and it keeps jumping around, this episode is for you. If you're sitting there thinking, look, we've done projects, we've tried to use less, and the bill still doesn't move the way it should, well, this is for you too. By the time we're done, you're going to understand what demand charges actually are in plain English, why one bad 15-minute period can wreck your whole month, what load factor is, and how to tell if a vendor actually understands your bill when they promise to cut your demand. I'm Daniel Burke, and you're listening to the TEG podcast. If you're a plant manager, a facility manager, superintendent, COO, or energy manager who never wanted to be in the energy business but got dragged into it because of budget and risk, well, I'm talking to you. Today, we're decoding demand charges, part 1. The question we're really answering is this: how can your facility actually manage and reduce demand charges in a way that lowers your all-in cost per kilowatt hour and takes risk out of your budget without pretending your entire operation revolves around utility billing? So let's start with the basics of the bill. On a typical commercial or industrial bill, you've got 3 pieces. First, fixed charges. These are just table stakes to be connected to the grid. They show up as a customer charge or a connection fee, and you pay them whether you use a lot, a little, or nothing. They don't care about your usage or your demand. Second, energy charges. That's cost per kilowatt hour. That's how many units did you actually consume this month. It's power over time. So if you have a 4 kilowatt load running for 8 hours, that's 32 kilowatt hours. That part, most people kind of understand intuitively. Third, demand charges. This is where things go sideways for most operators. Demand is in kilowatts, not kilowatt hours. So think of it this way. If you buy an 8-inch pipe, but only run a trickle of water through it, you're paying for 8 inches of demand. Demand is the size of the pipe. Usage is what actually flows through it. On your bill, the utility is effectively charging you for the size of the pipe that you bought during the worst 15 or 30-minute window in that billing period. The meter watches how high the stack gets during those windows. The highest average stack you hit becomes your billable demand. Another way to look at it is the all-you-can-eat buffet. Demand is like paying based on what it would cost to eat everything in the buffet, even if you just walk in and eat soup. You get billed on what you could pull, not just what you did pull during that one interval. So if an AC unit puts out 4 kilowatts and a water heater pulls 4 kilowatts, the stack is 8 kW. If you run them one after the other, though, the stack never goes above 4 kilowatts. Same total energy by the end of the day, but very different billable demand. You see, demand stacks. It's not averaged over the whole month. It is the highest coincident stack in one of those measurement windows that sets the number you get billed on. Now, why do utilities care so much about that demand stack? Well, from their side, they have to build and maintain enough capacity to handle everybody's worst case peak at the same time. Not the average Tuesday mid-morning, the worst hour of the hottest day when every chiller, every press, and every air handler is hammering away at the same time. That means they build generation and wires for the peak, not the average. Demand charges are how they fund that ready and dispatchable capacity so the grid doesn't fall over when everyone leans on it all at once. Now, in theory, the customers who pull the most volatile and stressful load on the system pay more for that behavior. But the truth of the matter is that is really just a theory. In reality, a lot of utilities are reducing baseload capacity and reserve margin while still collecting rising demand charges that were supposed to fund that margin. So the equitable recovery story is weaker today than the textbooks suggest. But you and I don't get to vote demand charges off of your bill. They're there. So the real game for you is understanding how they work on your specific rate and then using that understanding to control your all-in cost per kilowatt hour. The most important concept in this whole conversation is load factor. Load factor is the ratio of kilowatt hours you actually consume in the month compared to the potential kilowatt hours implied by your peak demand. The easiest way to see it is the 12-passenger van analogy, okay? If you buy a 12-passenger van, but you only ever haul 3 passengers, you're spreading the cost of that van over 3 daily riders. It's huge capacity, low utilization, a very, very poor use of your funds. That's what a bad load factor looks like. You bought a giant van and you barely filled it. So to improve load factor and drive your all-in cost down, you want to do the opposite. Month after month, you want to buy the smallest van you can reasonably get away with and then fill it as close to full capacity as possible with riders. In billing terms, the size of the van is your peak demand in kW. The riders are the kilowatt hours you actually use inside of that capacity. So balancing the two is key. If you drag your demand up, but your kilowatt hours don't go up with it, your cost per unit climbs. If you can hold your demand down and still run a lot of kilowatt hours through that smaller pipe, your cost per unit falls. That's load factor. Now, the flavor of demand charge you're on changes the game a little. Some of you are on a simple max or non-coincident demand structure. The utility looks at the whole month and asks, what's the highest 15 or 30-minute stack this customer hit? That one period sets your demand charge for the whole billing period. But some of you are on time of use demand. It's the same idea, but inside a defined window, like 4 to 9 p.m. That's essentially the utility saying our system-wide peak is here, and we care a lot more about your behavior in this window than at 3 in the morning. You'll see flat demand charges where it's just one simple fixed cost per kilowatt, or tiered demand charges where that number changes once you cross a certain threshold. And in some places, especially with experimental rates, you'll see daily demand charges where each day has its own mini demand charge based on that day's peak. Historically, this has mostly been aimed at commercial and industrial users like you, but you're starting to see demand creep into residential rates too, especially combined with storage-linked options. On top of all that, you've got demand ratchets. A ratchet is basically it's a preset reservation. It says, no matter what you actually do this month, you'll never be billed on less than this amount of demand. One example from a tariff that gets talked about sets a minimum billing demand of, let's say, 100 kilowatts. And then says that during certain months, your billable demand can never be less than 70% of your highest summer peak. So if you go out and set a 400 kW peak in August, and then November is relatively quiet and your meter only ever sees 150 kilowatts, you're not billed on 150, you're billed on 280, which is 70% of that 400 kW you hit in August. Practical implication? You cannot casually set some wild summer peak and then forget about it. You'll be paying for that decision in quieter months long after the event. And this is just one tariff. Some have fixed minimums, some have variable minimums tied to prior periods. The more complex the design, the less chance a normal operator has of reading the tariff and actually using it strategically. Here's the deal. The engineers and consultants who design these rates are almost completely divorced from your reality. On paper, these rate designs are supposed to be a practical guide for customer behavior. In practice, they're so complex that most commercial and industrial customers don't even know how to read the bill, let alone turn the rate book into an operational playbook. So if you've ever felt dumb looking at a tariff sheet, you're not dumb. The system is just that convoluted. So let's talk about what it means inside of your four walls. For many large users, demand charges are between 30 and 70% of the total bill, not a rounding error. A big chunk of that cash moves with the behavior you might not even be aware of. A single bad 15-minute period, a bunch of large motors starting at once, an HVAC control going haywire, a control system failure can set the peak for the entire month. You then pay demand charges on that peak, whether it was a normal operating point or a freak incident. That's why you can see bills jump even when your total kilowatt hours barely move. And that's where the common misconception lives. We used less this month. Why is the bill still so high? If you don't look at demand and kilowatt hours together through the lens of load factor, you never get a satisfying answer. So what can you actually do? Step one is real visibility, interval level data, not just the total on the bill. You need to know by time of day which equipment is creating those peaks and when. Without that, you're just guessing. And the only thing worse than doing nothing is confidently doing the wrong thing. But visibility alone doesn't cut your bill. Staring at graphs isn't a strategy. You need a set of principles and plays. Sometimes, with that visibility, you can do straightforward scheduling and sequencing. You might realize there are a couple of large loads that don't absolutely have to start at the same exact minute, and you can nudge them apart just enough to avoid stacking them in the same demand window. In some plants, that alone can get you a meaningful reduction. A 20+% cut in demand charges is not crazy in a facility that's never paid attention to this before. Other times, the operational reality makes that a terrible idea. If the only way to stagger is to add a third shift and the cost of the supervisor and support staff destroys any savings, well, that's a terrible trade. Energy savings always live inside the rest of your operating model. They're not in a vacuum. In more sophisticated operations, you can start to see tools like battery energy storage systems show up. They monitor your load in real time and discharge during peaks to keep the grid scene stack as low as possible. That can cut demand charges and sometimes smooth out your load profile. But these are capital projects. The payback hinges heavily on how demand and energy are priced in your specific rate and what they actually do to your load factor. It's not enough for the vendor to say, we'll reduce your peak. They have to show you how that flows through to your actual cost per kilowatt hour on your exact rate or tariff. You also have demand response programs. The utility or an aggregator will pay you to reduce your load during grid stress events. And that can be a second revenue stream on top of your overall demand savings. The trade-off, though, is disruption. When they call an event, you are on the hook to change something in your operation. My view is that demand response paired with grid-tied generation is often a better play than just agreeing to shut things off. When you can use prime-rated backup generation to keep your operations live, meaningfully shave your peaks, and participate in demand response events, you turn what used to be a stranded backup asset into something with multiple payback channels. Then there are efficiency upgrades, variable frequency drives on motors, better ramp-up profiles, better controls, and those can reduce how hard you hit the system on starts and in transitions. Again, the question is always, what does this do to my load factor and my all-in cost per kilowatt hour on my specific utility rate? When you have monitoring in place and you're paying, let's say, $750 a month for it, and the behavior changes and small process tweaks it enables cut $2,000 a month out of your demand charges. Well, that's $1,250 a month net, or $15,000 a year. That's real money. And I'll say this plainly. This is exactly the problem our virtual energy manager was built to solve. Monitoring as a service is not theoretical for us. No platform does this better than Tactical Energy Group's virtual energy manager. But before you do anything project related, I want to give you a filter because the vendor landscape around demand is pretty rough. Bottom line, unless a vendor can speak directly to your specific utility rate and show you accurately What your all-in cost per kilowatt hour will be after their project, they're guessing, and you're paying. I'd be very wary of any vendor who cannot do 4 things with absolute confidence. First, answer this straight. What impact will this project have on my load factor? If they can't explain load factor and how their project moves it, well, that's a problem. Load factor is the whole game for commercial and industrial cost. Second, use your actual utility data on your exact tariff to show you a before and after of all-in cost per kilowatt hour. I'm talking total dollars on the bill, demand plus energy, divided by total kilowatt hours. If they can't tell you with penny level precision what that number is projected to be after the project, there's not a chance. Third, run those numbers in a functional equivalent of your utility's rate calculator. Not a generic spreadsheet, a model that actually reflects how your utility's billing system works today, including riders and ratchets. Fourth, provide case studies from companies that look like you, same industry, same shift pattern, on the same rate or a very close cousin. Not, we did something like this once in a totally different context. If they can't clear that bar, all the glossy decks in the world do not matter. So let me zoom in for a minute. Every utility rate is a playbook. It's not a fixed take it or leave it number. It's a series of plays you can run. If you run them poorly, you can absolutely earn yourself a high all-in cost per kilowatt hour, even on a good rate. If you run them well, you can earn a very low all-in cost per kilowatt hour on a mediocre rate. Energy is the fundamental supply chain. Nothing you do in the critical path of your business gets done without it. With energy costs climbing and power quality getting worse, you cannot afford to treat it as a random, unmanageable cost or something the utility is supposed to manage for you. You need live data. You need a true representation of your specific rate. You need a working copy of how your utility actually calculates your bill. And most importantly, you need a best practice framework that turns all of that into better daily operations instead of another separate management layer. If that feels overwhelming, you're not alone. The complexity that's been quietly pushed into commercial and industrial customers is absolutely absurd. The vast majority of operators will never, ever have the time or appetite to hand calculate load profiles and ratchets each month. Your edge is not memorizing tariff tables. Your edge is asking the right questions and refusing to say yes to projects you can't see clearly in numbers on your bill. So let's recap this in simple terms. Demand-related plays are a winner when you can improve load factor. That means holding demand as low as is realistic for your operation while running as many useful kilowatt hours as you can through that smaller van. High utilization multi-shift operations that keep equipment running steadily often get more out of the current billing system as long as they don't do something dumb and set unnecessary peaks. They're also a winner when you have real monitoring and you can take relatively low disruption actions, small sequencing changes, modest control tweaks, smart use of storage or generation, and see in your data and on your bill that those actions are reducing demand and improving your all-in cost per kilowatt hour. Demand-related plays are a terrible idea when someone sells you on saving demand, but can't explain load factor, can't model your specific rate, can't show you your future all-in cost per kilowatt hour with their project in place, there's not a chance. It's also a terrible idea to ignore ratchets and set a huge peak during some unusual period, and then be surprised when you keep paying for that decision in quieter months. The single underlying concept I want you to walk away with is this: you don't manage demand and energy separately. You manage the relationship between them, and that relationship is called load factor. Look, I don't run your plant. That's your job. My job is to translate this mess and give you questions and leverage you're not getting from a sales deck or from the rate book. So here are a few questions you can take into a morning huddle with finance, ops, facilities, or your current energy partner. First, what impact Will any project we're considering have on our load factor? And can you show me that with our actual utility data? Second, based on our exact tariff, what is our true all-in cost per kilowatt hour today, and what will it be after this project if it performs the way you say it will? Third, can you walk me through those before and after numbers using a model that actually mirrors our utilities rate calculator, including ratchets and riders, so I can see how the bill is ultimately built? Fourth, do you have any examples of this exact type of project on this exact rate at a company that looks like ours? Can you show me in detail? If the people you're talking to can't give you clear, confident answers to those questions, then the safest and smartest move is to slow down, not to speed up and proceed with the project. Now, in part 2 on demand charges, we'll go deeper into specific plays operators are running with monitoring, storage, and generation to move their all-in cost per kilowatt hour in the right direction, and how to think about those in the context of your broader operations. For now, if all you start doing is looking at your bill through the lens of demand, kilowatt hours, and load factor, and start demanding better modeling from anyone who wants to touch your plant in the frame of energy savings, you're already ahead of most of the market. Thanks for listening to the TEG podcast. If this helped, send it to another operator who's dealing with the same headache, and visit www.tacticalenergygroup.com to get more practical tools for your facilities.